And obviously, if time permits, we'll try to cover few parts of regression, right? So this part already we have discussed, but I want to kind of look into the complexity of the problem, right? Let's say you say that, or you join a startup or you join a data analytics company. So they are helping a startup organization, right? Building application which will predict the traffic, right? Like your Google app or Ola Uber, right? One of their key kind of power of that Ola or Uber app is they can predict the time, they can predict the traffic. Though obviously they use the Google Map, right? So something similar to that you are trying to do. Let's say that startup is trying to do with certain little bit of value addition, right? So that is my goal, right? Whether it is a research goal or a predictive goal, and I'll differentiate what is the difference between a research goal, what we discussed in a business research method, and what is our discussion today, right? Predictive model, right? Then generally what we do, we make a hypothesis. If I want to just to understand, right? So just imagine the scenario, right? I want to predict, right, on a particular day, what will be the traffic in particular location, right? So what do you think which parameters I should take, right? What should be my parameters or variables or input variables or predictors which will be able to kind of predict the traffic size or the traffic density in a particular location. So there can be thousands of variables. I can take population data, I can take number of companies, number of schools, number of key kind of uh, institutions, let's say offices, IT park nearby. Then I can take a day type also, weekday, weekend. I can take, just imagine this situation which has happened. This is a new parameter, a new variable which has come, whether lockdown has happened or not, whether there is a curfew or not, right? Then whether there is certain road construction is going on or not, right? So this lot depends upon my imagination, right? And if I just run along with my imagination, I'll try to put 20 variables. And if I say that, okay, others or somebody else, you start building a model, you based on your imagination or based on your understanding, will try to take different type of data sources, right? So when I build a model, my model will be completely different from you, right? And my results or my predictions might be completely different from you, right? So then now the problem happens how to kind of because just imagine like they are appointing you, they are kind of giving you money, salary to build a very excellent model. But unless you understand the business problem, unless you have the clear understanding about that this kind of problem, it sometimes it might come from the common sense, sometimes you need to have a business understanding, and that's why I told you how important. So when you talk about data analytics, we only focus on the data part, we don't want to get into the business part of it, but business is much more important, right? You have to understand same algorithm regression. When I put a marketing use case or a marketing data set, my understanding has to be on how retail works, what kind of promotions on which day, what kind of customers, what kind of categories of customers, what are the product SKU means, right? So I need to have a different clear understanding of those marketing or sales or marketing acronyms or sales or marketing concepts, right? But same model, regression or logistics regression, when I put in a finance use case, I need to have a clear understanding of financial terms, financial use cases, right? What do you mean by credit score? What do you mean by default? Right? What do you mean by non-performing asset, NPA, right? So this is where, like I said, based on which area you want to get into, try to kind of build or kind of try to work on different projects on that. If let's say your most of your analytics might be the second area of choice. So depending upon which you have taken out first, let's say HR, right? Some of you might have taken HR is your first area of choice. So try to work on certain projects which is related to HR. Mostly HR projects will be on the attrition or performance measurement, right? And lot of data is available on internet. And then try to, which is our next discussion point. Getting the data is not a, obviously in a company it will, they will know how difficult to get data, but when for the academic projects, once you get the data, now the point is formulating a problem, right? Because up to now, what used to happen? We used to give you a question or a problem, you wanted to solve it. So today, what I have given you in that exercise, try to clearly write the problem statement. So try to clearly write the predictive problem statement. This is what we'll discuss in the next slide, right? Or next or after 2 slides. So my problem statement can be of different types. So here it is basically in a form of a hypothesis. I want to understand whether will be a very good predictor of a traffic density or a number of people who are moving right on road. If that is my, I have done certain exploratory research and I understand I have been in that industry. Let's say I have worked in Uber or Ola for last 5 years. I have utilized or I have worked in that kind of application. So I have certain prior experience. So I'll say yes, we can definitely take that. But my point is, you need to have certain base, or you need to have certain understanding to get that variable, right? Otherwise, if it is just based on your imagination, lot of things can happen, right? Lot of variables you can take, which is not possible to manage those number of variables, right? Then collect the data, right? And that is where we have discussed so many times here, like for today's exercise or your for classroom final exam, most of the times data set we are giving, right? But actual problem happens, what kind of data you are going to collect. Let's say for that startup, weather data, collecting weather data might be easy because they can get it from Google Weather. They might have to pay a certain amount of dollars per month based on the subscription. But some other data, it will be very difficult to get. So that is something as a data analytics executive or manager, you have to have that clarity that what kind of data a company can get or what kind of data they cannot access, right? So if let's say one of your kind of uh, input variable is getting the location data of each individual person staying in that area. So as you know that Google Map is basically they are assessing our, let's say whether you have iPhone or Android. So they are assessing our mobile data, right? Based on that, they are judging. So the algorithm is running. The input data is basically our location data, right? Based on our movement, traffic data gets updated. But Google has that kind of capability because we are using their platform. But for a startup to get that kind of data, either they will not, obviously they will not able to get. If they want to get that data, they have to pay a lot of money to Google, right? And that's why if you see like a lot of this Uber and Ola, they're moving to own a GPS system. Otherwise, what will happen every year? They have to pay a lot of money of using Google Map, right? And this is where the big dilemma happens. You know that this data has a significant predictive capability, but company won't have access to that data. As a small startup, they might not have that much amount of money to pay subscription fee to Google, right? Or they might not have that kind of technology to get this location data, right? So train a model using this data, right? So the first area or first kind of step is to build a very simple model, right? So always regression is the best if your kind of data sets show some linearity. Start with a simple regression model, then only jump into complex, right? We talk a lot about neural networks, your decision trees, your kind of other kind of algorithms, but most of the times simplest regression will help you a lot, right? 60% of your whether predictive modeling or machine learning problem can be solved with a regression model. Obviously, you need to hypertune some of the parameters, but still it can be done with regression. Is this model better than existing systems, right? So this is what. So this is where baseline model, right? If I have a very simple model, I'm not creating a predictive model. I would have certain assumptions about my traffic today, right? So let's say I have traffic data, everyday traffic data for last 5 years on a particular location, let's say Bhubaneswar, Patia location near Kit area, Toj, 1 kilometer radius or 2 kilometer radius. I have that data that what is the traffic density, right? Or the number of people moving around, right? each day wise, time wise, I have the data, right? So without building a model, without going into the this predictive analytics, right? If I ask you to kind of predict something, what will be the kind of traffic density tomorrow? How will you do that without going into the predictive model part? Any idea? I hope my question is clear. Without doing any kind of modeling, you have the only data is traffic density for last 3 years or 2 years on a particular location. So what will be your prediction or what will be your forecast for traffic density tomorrow? How will you get about that? Anyone? Or let's say take a example which might be closer to your heart, right? And I guess we have discussed that earlier also, right? Each year, all the MBA colleges kind of put their average salary and all those things, right? So the idea is, for a student, can I predict his salary based on whatever information I get for that student, right? So that will make our life easier, right? If I have the all the information, educational background, income background, which kind of schools, academic achievements, extracurricular activities, all the information about the student. I think most of the information is available at the college or university. Can I predict the students, let's say CTC, once he or she post graduates within next 4 months? What will be the CTC with which she or he will be graduating from the university? So I might build a predictive model. I taking different input parameters, taking my own understanding about the this kind of setup. I can create a model, and my model will predict the based on student characteristics what is the final CTC, right? But let's say I will not create a model. I do not have information or knowledge. I cannot create a model. But still, somebody asks me to, can you predict what will be the salary of that student? So what will be my prediction, or how will you go about my prediction? Anyone?
So the average amount that has been that the CTC has been gone in the last few years, we'll just consider that because no other information is there.
Correct. So this is the simplest one. That is your baseline model, right? Whether you take a mean, median, mode, that is up to you, right? So if that information is available with you, right, you need not have to build a predictive model. So you will say for each of you when you join your this Anessa, what's your roll number?
So 288.
Okay. So once you join this college, right, you had also that assumption. Kuch nahi hoga to I'll get this average, or and with that assumption you have joined this at least, or at or kind of that is the average salary, right? So if I do not build a model, if I do not have the capability or the data set to create a predictive model, I can just go with my baseline understanding that okay, for each of you, each of your student, I can take my prediction as average whatever CTC for last 3 years or 5 years, or maybe the previous year only, and that will be your predicted CTC, right? So why we are doing this predictive prediction, right? Why we are creating this prediction? Our attempt is to, if you are doing that much effort, if you are kind of creating this much effort to build a predictive model, it should be better than the baseline model. And baseline model is always the average one, right? If I have a continuous variable, my baseline model, most of the times we take the average value as my baseline model. So now the question is, and regression, the basics of regression is on that. Can I predict something for each of these participant or each of these student, which is better than the average? Because if I do not create a predictive model, I can just say that okay, they will get around 6.5 or 6, whatever the average CTC. But now by building the predictive model, how close I am to their actual CTC? Let's say each of you will get into a different range. Some of will be higher, some will be might be little lower, right? On an average, it might be 6.5. But now what I'm doing by creating that predictive model, I'm telling, okay, this student will get, based on the background, based on the effort he has put in these 2 years of MBA, he or she will get this kind of CTC. That is my prediction. And how am I doing will be based on how better I'm doing in relation to the average model, the baseline model which is there, right? If I'm not able to do better than that, then ideally I should not put my focus or effort on this kind of predictive modeling, right? So reach a conclusion again. So when I say is this model better than existing system, different companies depending upon the kind of, let's say for a bank or for a any kind of insurance company, right? Without prediction also, earlier without this machine learning algorithms, prediction algorithms, they might be using certain simpler heuristics, right? Heuristics are basically thumb up rules. Somebody who is a smoker, I'll not give them a or I'll charge 5,000 rupees premium. So that is the rule of thumb. Some manager, some marketing manager or product manager has told like that. So they have not gone through the kind of this approach, right? So that might be their baseline model for each smoker. If somebody is declaring themselves as a smoker, so kind of you are kind of charging them 5,000 rupees more premium, right? And that can be a baseline model. Now the point is, by building this prediction model which will predict the profit of how much insurance company is making from each individual, can I predict a better premium amount for a smoker which will increase my profit, right? So that is what you have to analyze, right? It is not only running a regression or a classification, a decision tree, neural network. It is about, by running that model, am I doing better than the existing system, right? Reach a conclusion, right? Based on that, you have to at the end, yes, this is a good predictor, I can use that for my predictive model. Then only, not only that you have taken a good data set, you have to understand also whether that data continuously will be available or not, right? Then if your data is not working, again refine your hypothesis and repeat. So it is an iterative process, right? It is not that you failed and you will leave it, right? You have to keep working on that. If there is a requirement from management, you have to keep working on that. So articulate your problem. So this is what we'll discuss in the next class, and this is very important. Start simple, kind of like I said, start with a very simple model, kind of without getting into the complexity of. Once you get into the, which we'll discuss maybe 3 4 sessions down the line, you will understand that how difficult it is to interpret those kind of models, and that is why people become reluctant to use those kind of complex models. Identify your data sources, because yes, I have given you 2 days for exercise your data set, and whenever there is a class, I'll give that. But in the actual scenario, understand that whether when you deploy that kind of model, whether actually you will get those kind of data. Because if you do not imagine that, if you do not kind of able to anticipate that, it will be very difficult. So you have created a model, but data is not available for your production, data is not available for your kind of final launch, right? Just a moment, I have a call. Sorry for the disturbance. So back we are where we are at. Identify your data sources. Kind of you have to understand where that data is coming from, right? Imagine a scenario like where kind of Amazon or Flipkart, they are predicting that okay, which customer or which kind of customer will buy certain kind of items, right? If they have taken a data based on their which kind of application they are using, or how much their mobile usage versus their website usage, matlab, the ratio of Amazon app usage versus how much time they are like kind of purchasing through Amazon website, right? So if they have taken that kind of input variable in a real time, you it might not be available each day, each minute. Company might not have access to that kind of data, right? So that is something you have to remember when you are building this kind of model. Design your data for the model, which is today's discussion is basically data processing, how to prepare your data for the model, determine where data comes from, what kind of data. So sometimes it might be like I said, uh, right now I think Uber have moved, they have created their own kind of mapping system, but when they actually started, they used to pay a lot of money for using Google Map, right? So and that is where their one of the major cost source, because they used to pay a lot of for using Google Map subscription. So for a company, it is not necessarily that all the data they want. Some of the information they might have to bring out from the outside participants, right? Subex is a company like that. There are many companies, right, who work on the telecom, like kind of the kind of data usage, how much time you are using your mobile phones. So they carry out a lot of data analytics on your mobile phone usage. So a lot of companies like Uber, Ola, your Amazon, Myntra, Flipkart, all of those partner with those kind of companies to get this kind of information, right? Ability to learn, right? So your model should be flexible that each time you get certain new insights or information, your model should be revamped, right? Your model should be able to update. Think about potential bias whenever you are collecting data uh, based on, so experience is a good thing and a negative thing also, right? Sometimes what happens, we might be biased towards certain information, certain data set. Okay, let's collect this kind of information, right? Or let's collect this kind of categorical information or continuous information, right? And that is what you have to avoid. And that's why I think whenever these kind of models get created, it is never an individual effort. Lot of people, it need to be team effort. Any questions on this? So this is important, and which I have asked you to do, right? I have given you a data set, right? And I have not asked like written what is a problem, right? Now you have to write that problem. So you have that information. Now think yourself as a data analytics executive and think that from that data set, what I am trying to predict, right? So there can be like generally there are two type of prediction classification, which category to this belong to, right? Let's say you there is a movie data, right? So I can say that whether this movie will be a flop or a hit or a super hit, right? I can predict that depending upon a lot of information. So that can be classification algorithm, right? Or I can include a regression algorithm where I am predicting certain continuous variable. That means how much money that how much crores of rupees this movie will make on let's say OTT platform or on the cinema halls, right, combined. So in that case, whenever I'm predicting certain continuous variable, so that becomes a regression problem. Whenever I'm predicting something categorical variable, that becomes a classification problem, right? Whether the movie will become which kind of whether it is a semi hit, hit, super hit, mega hit, or whatever the classifications are that exist. Can I predict that? That will become a classification algorithm, right? So now for this problem, right? Because I've told you to kind of run regression. Now you have to frame that problem, right? So for and this I've taken from Google only. So they, because YouTube they use lot of algorithms to predict how much which YouTube videos will get popular, right? So It can be like simple. So what they want to predict, we will predict whether an uploaded video is likely to become popular or not, 0 or 1, whether it will become popular 1 or won't become popular 0, right? So it becomes a classification problem. Or they just want to predict how many number of views, or much number of hours, how many number of hours that video has been will be watched, right? That is something they want to predict, because which one a bigger number comes, bigger number predicted, so that they will be putting into the kind of their platform, right? Will predict an uploaded video's popularity in terms of number of views it will receive within 28-day window. So that becomes a regression problem framing, right? So in this particular case, I have already mentioned we have a regression, you have to run a regression problem, right? Then now you decide how to write that problem statement, right? How to write that prediction problem statement. So that is, like once I upload the class exercise, so that will be one task you have to mention. So I have not asked, or I have not given a problem statement for you. Is this part clear?
Yes, sir.
So this is the important part. Anytime you join, right, nobody is going to give you a problem statement, right? So you have to, most of the times you have to frame a problem, right? So what they will give you, okay, where is the other thing? Okay, that might be towards the end. Okay, we'll come back to that. So for that to happen, once you frame your problem, right, now I have given you a data set. Most of the times it won't be available in actual corporate scenario. You have to kind of, there will be databases, different databases. You have to put a lot of SQL queries, extract that data, go through it, and that is where you need to have use data visualization, right? To find outliers, minimum, maximum, standard deviations, missing data, percentage of data missing, right? So basically, data exploration has to happen, right? Before you start doing regression and all those things, right? And that is also I have asked. Uh, so in SAS, if you see SAS Studio, right? So there is something called missing data exploration. So try to see that whether there is missing data, right? Though I don't think there is much, but try to see if there is any missing data, right? Try to carry out different visualizations, scatter plot, box plot, right? If the time permits, towards the end I'll show you. uh, I think all of you know where that kind of tools are there. Just you have to double click that, and you have to upload the data, and it will give you the results, right? Run symbol, and it will give you the results. So this is the overall step. Data sets, then you retrieve data or extract data, and there is something called data preparation, right? In some other classes also you might have covered the same process, right? But again, like quickly we'll go through it and we'll understand why it is important, right? Then the modeling part will come, where you will run a regression or a classification algorithm. Then after 2 or 3 classes we'll come back and see that how to hypertune parameter, like kind of hyperparameter tuning, all those model evaluation and model kind of updation happens. So it is a iterative process. So what do you mean by data preparation, right? Once you extract data, data might not be in a kind of a good condition, right? Because different kind of users, different database owners will be keeping data in different formats, right? That might not be exactly like today what I have given you in Excel format, right? But when you work in a company, there might be a few CSV files, few Excel files, a few Microsoft Access files. So now what happens? Combining that data, you have to kind of create a whatever uses of data warehouses or data mart. You have to get those data out of that and put it in a proper format where you can use that, right? Try to see that whether data uh, kind of properly labeled or not. There is not much missing data. If missing data is that, what kind of treatment you will do, right? Whether you need certain data transformations, right? So all this need to be done step by step, right? So first step, so when I say step by step, again it is a iterative process. Sometimes you might have to go back and see that okay, a lot of data is missing, we have to take another input variable. So it is not that once you complete data processing, it is not that you will not come back to that, right? So but generally, once hopefully you have cleaned the data, right, you get into the feature engineering part. So what do you mean by feature? So remember what we discussed. Features are nothing but those your predictors or the independent variables, right? So let's say I want to predict a person's CTC, a student CTC. So that is my output variable or outcome, right? So that is what I want to predict. But using what? Using certain input variables. Input variables might be age, gender, income group, uh, whatever, like let's say education level, then 10 percentage, 12 percentage, graduation percentage, MBA percentages, CGPA or whatever it is there. Then the kind of let's say communication skills, data interpretability or logical skills. So all those, if I have the information, right? So those are input variables, right? So those are nothing but features, right? So now this step feature extraction engineering will happen. Then later on, out of those features, sometimes what happens, if you have lot of features, you have for your model, if you have taken hundreds of let's say 200 of features, 200 of input variables, your data might work very well for your training, testing or validation data, but when it goes for the production, it might not work well. So that might be a case of overfitting. Anyhow, we'll come back to that overfitting, underfitting, what does actually it mean. But know that if you have a lot of features, it is not always good. Lot of input variables, kind of it might show you on paper or output very good model, but in reality it will not give you good results. So we'll try to understand each one of them kind of one by one, starting with data processing, then feature engineering extraction, then feature scaling selection, right? So data pre-processing, right? You might have first step with the data cleaning, right? You might have missing values. So one treatment might be remove those missing values, right? If 20% of your data for certain features, certain input variables, more than 20% of input data is missing, you might think of not taking that as a input variable, not taking that as a feature, right? Or imputation, data imputation, which is a, if missing data is there, let's say I have a kind of for student data, I have those 300 students data, right? So out of that, I do not have age data for 20 students or 10 students, right? And it is not possible to go back and ask you, right? You have not furnished that data, right? In that case, what I might do, I'll take your average of the class age, average of all your batch size, 300 student. What is the average age? Let's say 21.5 or 22. So I'll impute. So rather than putting 0 on the age, because data is missing, data is not there, not available is written. Rather than taking that, I'll just put 21.5 or 22, whatever the average or median data or mode data, right? So that is data imputation, right? Then there are other methods also. Once we get into the modeling part, we'll try to see. Then categorical data, right? So how you handle categorical data? Obviously, if it is missing data, there is missing data, then you have to see which might be closer to that, right? Let's say in this insurance data which you worked in the previous class, some of the states are missing for some kind of participant, right? So that is a categorical data. How will you interpret that? How will you, so you cannot take a and work on that. Let's say for 10 participants out of 1300 customers, for 50 customers you have missing data, they do not have state information, right? Then again you can take the mode, right? The most number of, let's say from Andhra Pradesh or Uttar Pradesh, most number of people are there, though it might be incorrect, you might take that as their state, right? Then how do you actually work for categorical data in your model, right? So sometimes it is done automatically, but if you are using a kind of a open source platform like a Python or R, you might have to write few codes around it, right? Because a algorithm cannot, or a machine cannot understand what do you mean by apple orange, or let's say you have done a PhD, masters, or let's say BTech, BSc, right? So they will not able to understand, right? And it becomes difficult also. Sometimes if you have done BTech or let's say BE, though both are from engineering, both are means like kind of in the same field, it might understand it differently, right? Or sometimes there is a B capital, some of you have written B capital, T capital, ECH, and some of you have written B small, T small, right? Or a lot of combinations, permutations might happen, right? So in that case, what happens? It becomes very difficult to go one by one and try to kind of change all those spelling and all those things, right? So lot of reasons why we use this data encoders. Some libraries in Python are there which are auto encoders, right? You need not have to write any code, and automatically if you run the package, they'll be able to do this auto encoding. But what does it mean, right? So it means basically I have a categorical data. I am changing that into a number, right? Some numerical data, right? So that is the encoding coding part which happens, right? So there are basically three types. Again, there are I think 10 or 11 types, different versions of these three major ones. But we'll try to focus and understand what these three types of encoding means, right? Then numerical data. When we have, let's say, different uh, type of data, right? Numerical data, numbers, but different type of numbers. So what happens? Age, right? When I have, let's say, age data for students, I know that generally it will be between 15 to maximum 25 or 30, right? So at least if I'm predicting something for Kids School of Management students, 18 to 25 or 24, that will be the average age range. So I know the limit range of it, right? But when I look into the income background, right, income background will have a bigger number, starting with the average kind of annual income for family maybe from 3 lakhs to 30 lakhs or more than that, right? So the range becomes higher. Or some, let's say, CGPA, your average percentage or CGPA. So if I am taking CGPA, it will be limited to 10. So 0 to something between 0 to 10, right? So different numbers, different kind of features, where there are continuous variables, they will belong to different range. Sometimes what happens, for your predictor, for your outcome variable, certain predictors which have large numbers, let's say income, or let's say your certain numbers which is kind of highly inflated, right? So that will seem to have larger impact on your predictor. It will seem that, okay, somebody who is from a higher income background might find a better cities, right? Which might not be true, right? To avoid those kind of predictions, to avoid those kind of problems in predictions, right? So we try to kind of uh, normalize or standardize the data, right? So there are different type of standardization or normalization, but we'll focus on two of them, right? Then towards the end, data discretization, right? It is again kind of similar to your labels, what happens for a categorical variables when you do it for a continuous variable, right? So let's say this age group, right? Or the income, if I directly ask your income group, so rather than everybody putting actual numbers, let's say somebody put 2,78,000, somebody put 5,20,000, somebody put 6,50,000, like that, each one of you, let's say, mention your annual income of your family, right? So rather than handling data in that, so there what happens, this is a continuous data, so I'll try to change it to into different labels, right? Like we did for BMI, right? So different BMI numbers was given last to last class when you did that categorization. Exactly, that's what we did, right? So lot of information on BMI was given, right? So what we thought, rather than taking BMI number as a data point, what we changed that into three categories, right? So we told this is kind of good, this is overweight, and this is obese, right? Somebody who is below certain BMI number, so he is maintaining good health. Then let's say 25 to 30 overweight, above that is obese, right? And that is what we just did, data discretization, right? Again, there are many ways of data discretization. Some are manual, some are automatic. Gradually you'll come to understand that, but these are the few steps in data pre-processing. So data cleaning, fill in the missing values, smooth noisy data, identify or remove outliers. Outlier analysis we have not covered, we'll cover. There are a lot of steps into outlier analysis. I'll show you that in hopefully by next class. resolve inconsistencies, right? Sometimes, like I said, simple inconsistencies, same thing. New Delhi, Delhi, right? If some of you have taken Tableau class, you'll find those kind of issues in dataset. Place some time it will be mentioned New Delhi, in some data file it will be mentioned Delhi, right? How your model reads it, it will be might be little different. Data integration, like I said, some files be from the CSV format, some Excel format, some Access format, right? How do you integrate and create a data cube so that your model can read it? Data transformations, there are again different depending upon categorical variables, depending upon your continuous variables, different type of data transformations can happen. Data reduction, or often reduce representation in volume, or like kind of the number of information you have, number of parameters you have, rather than using all of them, you try to reduce number of parameters you are using for your model. Then data discretization, right? Like I gave that example, we had BMI numbers, BMI as a continuous variable. Rather than using a continuous variable, we change that to a categorical variable and try to see that whether it is helping our model, right? So that is my assumption, that if I change that to categorical, so I'll have better interpretation rather than using that as a BMI continuous variable, right? So, this is like a label encoding. So let's say poor kind of educational kind of marks, or let's say your educational records, poor, good, very good, excellent. It is something like that. It is there, right? Or your experience for last 2 years of MBA. So you have given your experience in the college in different grading, right? Poor, good, very good, excellent, right? So what I'll do, I'll rate that, or I'll encode that as poor as 1, good as 2, very good 3, excellent 4. So this is something which I'm doing a label encoding here, because ordinal, because I know that 2 means it is better than 1, 3 means it is better than 2 and 1, 4 means it is better than 1, 2, 3, right? One hot encoding and dummy encoding is basically for your variables which do not have ordinality, that means no order present, right? Nominal data, nominal means only names, right? So red, green, blue, for me all the three colors are same, right? So that is, those are the only names, right? So I do not see any differences. But here, if I just show this, everybody will know that okay, good is something higher, right? Better than poor. Very good means something better than good. Excellent means something better than very good. So those are ordinal variables, right? But here these are nominal variables. So whenever we are coding nominal variables, we might do it as on one hot encoding. So what does it mean? Red I'll represent with, so all these information will be represented on three variables, d1, d2, d3. So it is like a red means 100. It is a vector which shows x direction 1, y direction 0, z direction 0. Again, it is arbitrary. I can say, so it is not that always I have to do red 100. So it is up to you how you are representing. I can say red is 001 also, right? It is automatically, either you decide or let the model decide automatically, right? But what does it mean? Only one variable will have one value, other all the variables will be 0. So how do they decide number of variables? Number of labels are there, right? So color, I have three labels, red, green, blue. So there are three variables created, right? D1, D2, D3, each of them has, let's say green means D2 is 1, other 2 is 0, right? So if I write this, that means automatically the machine will understand this is a green color, right? Dummy encoding is little different than one hot encoding, where you are creating n minus 1 variables. So I have three labels, red, green, blue. So I'll create 3 minus 1, two variables. So this makes number of features, number of predictors less, so model might perform better. Just imagine if I have that creating for state, different categories are there, and each time I'm creating n variables, and I have 5, let's say, categorical variables, it becomes 5 n variables, right? But if I'm creating dummy encoding, for each one of them I have to create one less independent variable, right? So dummy encoding, in this case, I create two variables, red is 10, green is 01, blue automatically takes the value of 00. So here if you see, it is similar to say that there is another variable called d3 which takes a value of 1. But rather than telling that, what I say, whenever I write d10 d20 means it will mean that it is a color blue, right? Rather than putting another variable called d3 is 1, right? Which used to happen in one hot encoding. That means each label will have one variable for each of them, right? So this is how you kind of change your categorical variables to numerical parameters so that the machine can understand, right? Is this clear or any doubt? Any questions on this?
So the dummy encoding is also for the nominal value, right?
Yes,
Okay, sir.
both dummy and one hot encoding is for nominal values. Label
Yes.
encoding is basically for ordinal variables. So your basically categorical variables are two type, right? If you remember what we discussed in BRM, right? Categorical variables, we have four types of variables, right? Nominal, your ordinal, right? Then interval and ratio. Nominal and ordinal are basically your categorical variables. Interval and ratio are basically continuous variables, right?
Yes, sir.
So I hope all of you remember the difference between normalization and standardization. Normalization means whatever input data you have, it doesn't matter how big, how small, right? All of you kind of put a scale of 0 to 1, right? How do you do that? Again, there are different type of normalization. So this is max min normalization. Then you have something called which you use basically Z normalizations, right? Where you kind of use it in a standard like kind of normal distribution. So here what we are changing for each variable, let's say I have income group, right? Income data, right? Each one of you have told your family income, right? So rather than just mentioning X, so for each of the income data, I'm changing it as X. Let's say minimum, X minimum is let's say 2,50,000, right? And X maximum is let's say 70,50,000, right? So now let's say this X, the income is 5 lakhs. Some one of you has told my income, family income is 5 lakhs. So in the original data, all the information is there. Now I'm changing that. So what will happen the exchange? 5 lakhs is the original data minus X minimum. Minimum is 2,50,000. Again, I'm taking an example. 5 lakh minus 2,50,000 is 2.5 divided by maximum is 17.5 lakh. 17.5 minus 2.5, right? 15. So 2.5 divided by 15, right? So 1 by 6, right? 0.1666, right? Or 0.17. So now what happens, rather than kind of writing 5 lakhs or as income group, so 5 lakh has been converted into 0 to 0.17, right? So that becomes your changed variable, change number for your X, right? But if I want to do it for a standardization basically reduce the data, rescales the data to mean as 0 and standard deviation as 1. So what it means is how kind of far or how close this income is close to mean, right? So what it means, let's say your let's say income data is given, right? Every one of you 300 350 of you have given your income data. Let's say average is coming around 3.5 lakh or 4 lakhs, right? So when I'm standardizing the data, right? So that average, actually I'm forcing that average to become 0, and standard deviation, let's say standard deviation is 1 lakh or standard deviation is 1.5 lakh, and I'm forcing that 1.5 lakhs to become 1. So how it will happen? So let's say same thing for the person who has a family income of 5 lakh, right? So 5 lakh minus average of all the income, average of all the incomes is 4 lakhs. 5 lakhs minus 4 lakhs is uh, 1 lakh. Then divided by, let's say standard deviation is 1.5. 1 divided by 1.5. So whatever the result is coming, 2 by 3.66, right? So what happens means this person, if I take average income as 0, this person's income is 0.66 standard deviation more from the average income, right? It is on the right side. 0.6 means higher side. 0.66 standard deviation higher from the mean income, right? So this is the way to interpret it. Why do you do that? Like I said, sometimes somebody having a huge income, let's say if I take the income data, it is in lakhs, other data is in let's say if I take your age data will be two-digit numbers. Your percentage data also will be in two-digit numbers. Your CGP data will be in uh, again maximum 10, otherwise single-digit numbers, right? So automatically what happens, because this is a higher numbers, right, bigger numbers, it will try to influence the prediction, right? It will, though it is not a very big predictor, though income might not be a very big predictor of your CTC, overall CTC of a student, but because income has been taken in numbers, right, automatically it will show that when your model is run, it will automatically show that as if your family income group decides the final CTC, which might not be true, right? And that's why whenever continuous variables are there, you might have to check whether this kind of data is there. Whenever income is not given in, let's say, lakhs or millions, and it is just given as a number, you might have to standardize the income, right? So mostly we use standardization. Normalizations rarely used, because sometimes what happens if I normalize the data, outliers in the negative side and the outliers in the positive side are gone, right? Because I'm forcing the data to fall between certain 0 to 1, right? Here it will be there. Here some information will be there which is more than 3 standard deviation, left side or right side, right? So that I can consider as outliers. But here I do not have any condition to understand which are the income, which participant or which student have a income which is a outlier, either in a very low side or either in a very high side, right? So mostly whenever data transformations happens for your continuous variables, we try to use this standardization. So what we do, for that original number which is given minus your mean value divided by the standard deviation value, right? So that will give you the X standard, right? Standardized X. So we understood the different, again, like there are additional feature transformations also, but this is something basically we try to do during data pre-processing stage, right? Any questions on this? So first stage, data pre-processing, which will take care of missing values, data encoding for categorical variables, some kind of data transformations if required, right? In terms of data standardization or normalization. That brings us to the second step, where we understand those variables, extract that, and some kind of engineering happens, right? So this is known as feature engineering, right? You work with those features, those input variables, try to modify them to fit your need, right? So features, if you see, if I this kind of data, age, height, right, all those information is there, number of kind of amount spent, all these information. So these column data are nothing but features. So those input variables are nothing but features. Each row represents a example, and each column represents a feature describing that example, right? Features are, remember what we discussed, those are nothing but your variables, right? Input variables. So feature extraction, turn raw data into features. So whatever data you have given, right? Sometimes data might not be in very clean state, right? You have to change the labeling, labels are not there, right? So all these things has to happen in the data pre-processing. Once you have that clean data, right, now we are changing and trying to sending put that labeling correct, right? Age, height, let's say your standardized income is there, you write that feature as a standardized income so that somebody understands it, understand the problem. Let's say in the data processing, pre-processing, it is written as income, right? So that was the input variable, but when you are trying to use that in your model, you have to label it as a standardized income, because now you have done that data transformation part, right? Because if you do not label that as standardized income, later on when actually you are using that for your final production, final output model, they will not remember whether income was standardized or not, right? Somebody else will be using your model. It is not that you are always going to use or run your model. Somebody in the production, somebody, some other data scientist or other executive might be running that. Unless you name that feature correctly, okay, it is a standardized income and this is the standardized method, so you have to put a comment, this is the because again, different type of standardization is there, right? Which kind of standardization you have carried out, or which kind of normalization you have done, right? Sometimes it is automated feature generation, right? So some models, SAS, SPSS, or let's say rapid miner, all those things automatically by reading that input data, right? Metadata, they'll be try to understand, okay, whether that a certain data transformation has happened or data encoding has happened, right? So once you extract the features, you have a certain idea about your input variables. You might want to do certain feature transformation, right? And this is where before this actually you have to conduct certain data visualization. It is not that every time you have to transform the features or transfer the input variables. So rather than using income data or the standardized income data or age data, you might want to use that they were showing you square of age, right? Or a inverse of age, right? That might be predicting a lot better, right? And that is something, again, it is not a permutation combination, right? Do not kind of try to do it, right? So you can do a lot of transformation for each of those variables, right? It has to come from the data visualization when you understood the data. Okay, I do not find a linear relationship between. So let me show you. I think last class there were towards the end very few students. Same example which we discussed in the last class towards the end. Just let me share the screen. So if I'm building a regression model, right? So let's say these are certain internship per month salary. And again, I've just created this data. And this is X is your age, right? So what I'm trying to predict, a person, how much internship amount per month he or she is getting, whether I can predict with the number of age. I do not have any other variable, right? This is a simple regression, a linear regression, right? So I just created in Excel a plot and I found out that regression line as y is equal to 162.15x plus 3000, right? X is your age, right? So, but R square is very small, 0.1184, right? So I'll try to see that whether I can use certain data transformations which might give me a better result, right? So now what I did, I just took the square of x, right? Ideally, I should have done this kind of scatter plot. From the scatter plot, I should be able to see that, okay, it is not a y-x relationship. It looks like y is equal to something plus x square relationship. Or whenever there is a short change in y, like kind of x, there is a big change in your internship income, right? So now once I use x square as my input data, right, rather than x here, right, rather than age, if I use age square of age, I am getting a better model, though it is again slightly because I'm just taking a single input. R square is becoming 0.1969. I'm not telling this is a very good model or this is something which you should do, but the idea is data transformation here only improving your R square by 8%, which is actually big, right? So 1.69, 19.69 is not a very big number, but it is still better than your 11 point whatever 84 percentage, right? So this is where your data feature transformation has to happen, and it has to, based on your experience, based on data visualization, you will be able to know that whether I need to have to carry out certain feature transformations. Is this part clear, or any questions on this? Just a moment. So different type of transformation is available. If you go to SAS, right, click on the double click on the transformation data, right? So here there is a drop down menu, right? Select your variable, which kind of variable you want to use, and different type of, if you click on the drop down menu, different type of transformation is there. Then there is a binning also, right? I'll show you later on tree based binning when we use that in the SAS enterprise miner. Say similar to data discretization. So rather than using different continuous variable, right, we put into bucket or different quantiles, right? So quantiles, as you know, we might use that in a box plot to interpret that, right? So this some kind of transformation, rather than different age group, I can put into different beans, right? 0 to 20 bean 1, 20 to 50. It will help me to better understand data, better interpret ratios. Or originally data was like this, I can put a log scale, right? Let's say your income data was available like this, right? So rather than taking income, I take log income, right? So that is something feature transformation we can use. Then once you have gone through your feature extraction and engineering part, right? Finally, you have to select some features, right? Not necessarily all your features are good predictors, right? So this part almost all of you automatically know if you have gone through the regression, right? There are different methods of how regression that software automatically selects, even the Excel also, right? In Excel also you can select whether it is a forward selection, backward selection, stepwise selection. Select k best, so you use k means nearest neighbors and try to use the best predictors, right? So these some of the features already you might be aware of. So when we actually run the regression models, we'll see, try to understand each one of them, right? So this is something where your advanced regression or the complex regression models, where you try to hyper tune those parameters, right? Hyperparameter tuning happens. So again, all these three will discuss, right? And there is another one also, least angle. Then filter methods, right? So there are different methods to select features. So remember what we are trying to understand. There are different features. There are different input variables. We know that if you take lot of input variables, our model might get overfitted, might get biased. We try to reduce that. How to reduce that? So this is the standard process where model I decide take one input variable, then next. So that is forward selection, or backward selection. Sorry, forward selection is take one, then next add one, then add one. Like that, you try to improve your model. Backward selection, when you have all the input variables, then try to remove one by one. Right. Stepwise selection, you have to select which kind of variable will go after what. Right. Filter method, what happened, you try to find out which are kind of highly correlated features. Because see, let's say if I say I have taken your income data, family income data, also I have taken your family expenses data, or I have taken your home value, your property value, right? That might be correlated. So some of you might have which might be from the higher income background, might have very good apartment or whatever, right? Monthly higher expenses, right? So if I'm taking both those variables, those are correlated. So my problem of multi-collinearity might happen, right? So from the beginning itself, I might able to remove that. So rather than taking both your monthly income or annual income and annual expenses, I'll take only one variable, right? Rather than taking two variables. So rather than selecting both the features, I'm selecting one feature out of them. Dealing with constant features. So for each of those, all the answers are same, right? Let's say I have asked you a question, have you, and that lot of times the problem happens with the data collection also. Have you completed your graduation? It might have happened in the beginning of your kind of MBA, kind of when you joined your MBA, because that time some of you might not have completed your graduation. You might was supposed to complete kind of your final exam or keep your final exam, but now when you are in second year, that question might not be relevant. Each one of you have said yes, so there is no differences in answers. Why to use that, right? So take out those features. Dealing with duplicate features, again, right? I have taken age and I have taken like same information in number of days you have completed, a number of years or number of days. Sometimes that kind of mistakes also happen, right? So dealing with duplicate features, right? Like that, I have to filter. I have to. So that is where the first step, data understanding, is very much important. You have to have a clear understanding of what kind of information you are collecting. So using different kind of method, this is anyhow like kind of any model will go through it. This has to come with your human experience, your data understanding, and this is little kind of, if you want to kind of improve your modeling, right? Improve your model prediction, the advanced regression methods we can utilize, right? So this is your feature selection, the input variables which you are going to use for your final model. So pre-processing, feature processing, then the data modeling part happens. You put those, if it is Python R, you might have to write certain codes. In SAS, it is again a drop-down menu, right? Now the question of which is most important sometimes in the exams also ask, right? What are the use of this training, testing, and validation data set, right? Sometimes it is only training and testing data. Sometimes there might be requirement of validation, right? Training data, what happens generally the ratio is 70-30 or 70-20-10, right? Or 80-20. So training data based on which you are basically selecting your kind of features and building your model, right? Most of the times validation data not required. You train your model. So let's say I have the information of this customer data of 1600, right? So I'll divide into 80-20 ratio. So 1200 data I'll take is a training data. I'll create a model using those 1200 information about 1200 customers. Then finally I'll run my model to predict, to see that whether actually my model is able to perform well in a new data set, right? So that is where the testing part of your model, let's say my regression model, I created certain equation. Now I want to see that that equation or that predictive model which I created is able to kind of uh, give the actual kind of result in a new data, right? So that is where testing data usage, right? Most of the time only you will have training data, testing data. Sometimes whenever you are using those complex methods or additional methods of hyperparameter tuning, you might have to use validation data, right? Validation data mostly used for this parameter optimization or hyperparameter tuning, which we'll again discuss. We have, because we have now started discussing on regression, right? So to answer, in case somebody asks you the interview, so training data is to feed the model, right? Validation data sometimes for feature selection or hyperparameter tuning. Test data is to basically final model fit, right? Most of the times we use only training and testing data set, maybe with a 80-20 or 70-30 ratio. In case there is a validation data set requirement, right? You say that no, let me kind of parameter tuning I'll do with my validation data set. You will take 70-20-10. It is again, there is not a standard rule, it is up to you, but most of the times people use in that ratio, right? Is this
So,
part clear? Yeah.
so that 80-20 and 70-20-10, I couldn't get that.
Yeah, so if you have only training and testing data set, right? So what, let's say I have that customer data set, 1600 rows are there, right? So what will happen if I build that, or if I ask my SAS or in Python or R, I ask that, okay, divide this data set into two different data sets. One you create as a training data set, one as a testing data set, right? So what will happen? Randomly, it will choose 80% of the data as training data set. So out of 1600, 1600 into zero point 0.8, right? How much? 1080, right? Or 1100, close to 1100, right? Information about those customers will be in the training data set. Balance 500 will be into your testing data set, right? So that is the meaning. So when you are building the model, you are not using all the data. You are using the data of only the training, that 1000, 1100 information. Once you build the model, now you are testing, you are checking whether your build model, whatever assumptions you took, whatever model predictions, that is remaining close to what you test trained your data for, right? Otherwise what will happen, just imagine you have built a model using all the information which you have, and you told that I am very much confident, but when you actually send the model for final production, that means a final use case, it is not giving you the proper result. So that is where your training and testing data set kind of used. Look into this way, right? Let's say you are kind of creating certain new curry, right? And you're in your final kind of at your home, you are preparing some food, right? So what will happen? And it is very kind of trial and error method. You are trying to use different information, right? So when you are using that, so you created something, then you test it, right? So you trained your model. Okay, you say that, okay, if I put these all the ingredients, this is testing good, right? The final taste is good. It is like a very good dish or a very good curry, right? But before going to the final, where let's say you will be preparing food for 200 or 500 people, right? You will again prepare that food with the certain same ingredients, same quantity, and you will feed your family, right? Or you feed your, let's say, try it, like your friends will taste that food, right? So that is where your training and testing we do, right? So you will have a training data set and testing data set. Is it clear, or any doubt on this?
So now, while selecting these inputs or features, it is the computer or the program that is selecting it, right? It
No,
is not
not
manual.
necessarily. Manually you have to give those information, right? There are
Okay.
kind of packages which help us to select features, but ideally it should be human intervention, right? Because it
Okay,
should
sir.
not be all thing from the machine, right? So all this feature selection and everything need to happen kind of, most of the part has to happen manually, right? So when I
Yes.
say manually, certain logic, human logic has to be there. So just imagine, like let's say for the traffic data, which kind of information you should take. Then if I take that information, what kind of transformation of that data should happen? Like let's say if I take the or let's say your final CTC data, what kind of input I should take? Once I take that, whether I should do certain feature transformation. Let's say your income is there, rather than just taking income, should I take log information, right? So that machine will not handle that well, right? Though there are certain packages being constructed. So that is something your intelligence has to come, that okay, rather than taking income, I'll take log income. Rather than taking age, I'll take a square root of age based on the data visualization part you have done. So this has to have certain human logic around it. So once you
Yes.
create your model, that has to be tested. Okay. Okay. So what is the time now? Okay, I'll stop now. Already close to today's finish time. We'll there are another 2 or 3 slides we'll discuss in the next class.
Sir, I missed my attendance.
One by one, roll number 008. Okay. Next.
2340.
340. Okay. Anyone else?
Sir, if we fail in this testing part, then we'll go back to validation, or do we have to go back to the
Training. Ideally training. So if your
Okay, sir.
testing fails, ideally you should go, because validation data set, generally 20% of the data set, it is only for the parameter improvement, right? Ideally you should go back to the training. There is something very wrong with your model. Ideally you should go
Yes.
back to training data.
And in training itself, we are putting this, putting the problem framing, right?
No. Problem framing has to happen before training data set. So this is the data pre-processing part. So pre-processing, everything will start. So now you are in the beginning, you have to formulate a problem. By having this data, what I want to achieve. So what do I want to predict, right?
Yes, sir, got it.
Yeah. Chalo, take care. We'll meet next class and start with the regression.